Hello. So, fast-phase boron has been moved here from Inspire 2. So, as soon as folks settle down, we'll go ahead and get moving. So, go ahead and settle in. All right, so how many of you have actually followed any of the fast-phased boron conversation on the mailers? Okay, cool, excellent. How many have no idea what fast-phased boron is? Oh good, this will be more fun. So, fast-phased boron. What is fast-phased boron? It's fairly straightforward. So fast just means that we do shorter release cycles. So rather than having a 6-month release cycle, we have something that's shorter, say 6 months, say 2 months, for example. Phased. So what phased means is that you actually phase the release process. So that first kernel releases, the kernel project's release, then the protocol project's release, then the app project's release. Now, so that gives you a phasing process whereby, for example, the protocol projects can always consume release artifacts from the kernel projects because kernel has already released its version of this, the version of the release that protocols is working on. So then, and of course, then what is boron? Amorphous boron is used as a rocket fuel igniter and in pyrotechnic flares. So it gives a distinctive green color to flame. So talking through what some of this looks like, right? Because it's not particularly complicated, but it helps to visualize things. So right now, the old life cycle has been 6 months. So we got 6 months, we're all coming together, and we release. So for the new cycle, you'd have basically 2 months. So you'd have a release in 2 months, a release in 2 months, and a release in 2 months. So phased. Phased is a tiny bit harder to picture, but it's actually not that complicated. So if the line you see on the screen represents the kernel projects, so the kernel projects would spend 2 months and they'd release their boron release. Then the protocols, 2 months later, would release their boron release. And from the place that you get the release from kernel, protocols begins consuming release artifacts from kernel. Now, this gives you a lot of nice effects if you're protocol. So how many people have occasionally had something upstream break you and you actually are stuck? I'm sure it's more than that. So the nice thing about release artifacts, if you're a downstream project like protocols or apps, is that you continue to get exactly the thing that you continue to get. So you do your development work, things don't change out from under you. And then, of course, apps, 2 months, right after protocols release, apps do their 2-month cycle and release. And then at the very end, you have the overall boron release, the little purple sun there in the picture, which is the point at which everybody has gotten their boron release out the door. Now, the natural question you may ask yourself is, okay, kernel has now released boron. What do they do now? Of course, the answer is they go on to do carbon. So while protocols is working on boron, kernel is working on carbon. And then once kernel has released carbon, protocols has now released boron, they start working on carbon. And the picture continues down the way. And of course, the question then, of course, is what after carbon for kernel? And of course, they start working on nitrogen. Are there questions? Right. So there is a certain priming. So go ahead, Avishad.
Yeah. No, I mean, as per this pipeline diagram, the carbon will be actually in November if this is in September.
Overall carbon
Yeah.
So overall, Boron would release roughly September.
Yes.
Overall, Carbon would release roughly 2 months after that.
Yeah.
Yes, please. So I guess the main idea here is that the protocols in the apps, they have a stable target, right? That's not moving.
It's certainly one of the things that's beneficial here, yes.
But there's going to happen the case where there's a bug. I find a bug in, if I'm in protocols, I find a bug or a problem in kernel.
Yep.
And I guess you're going to address that, or how would that work? Would it be like stable branches from previous? And what if all of a sudden I realize, oh crap, I forgot that I needed another feature from upstream?
Right, so you've got a couple things to answer for that. So the first thing you asked is basically, what about bugs? So clearly, you have to, when kernel releases Boron, they have to have a stable Boron branch. And clearly they need to do SRs. Now, the current proposal for dealing with bugs, presuming when you find them after you're on release artifacts, is that this SR is released, say, 4 weeks after the initial release, which is the halfway point for kernel. So basically you get these steps that go out for kernel relatively swiftly, but there really are strictly only for bug releases. One of the unfortunate problems we've had is because our cycles are so long, we've had a ton of pressure to put features in RSRs, which we have not always resisted. But if, to your second question, what happens if I discover I need a feature? If the answer to, oh crap, I'm 3 weeks in and I've realized I'm missing a feature is, dude, I'm really sorry, that's going to be another 4 weeks. That's much different than I'm 3 weeks in and I realized they need a feature and, oh crap, sorry, come back in half a year. So part of it is it reduces some of that pressure. Yes?
The second question is not to necessarily to you, but more to Phil. Is the community, I mean, in terms of the release dynamics and things like that, where we have the press release, where we have things like that, are we okay with a release every 2 months? I mean, currently the way we do the release, we have the press release, we have it's a bit of a big affair. Will it be a little too much for in terms of the logistics? And the second thing is, will the users tire of having a release every 2 months? I mean, the users of the news community over.
And just to widen it a little bit more, the question, fast seems scary to me because of the overhead we have when we release for people like Ann. And now if we're worrying about that every 2 months and it's taking 2 weeks of our lives, then when are we doing real work?
Yep, no, I'm happy. I actually have an answer for that. But let's hear, let's cue it up, man.
Yes.
Phil, so concise.
So I don't think it would be too much of a problem from a press release standpoint, but I do think we will scare our users away if we are providing what we say are equivalent releases on a 2-month basis. They will have a hard time figuring out how and what to consume. So we might want to think about differentiating releases as something lighter weight for a couple of them and then heavier weight for another. That would, again, slower the whole heart palpitations of our users. But I have a feeling that was kind of already part of the plan. So I think that's how you adjust for that. But yeah, if we did release every 2 months, no, our users would be generally unhappy. And I think, again, our own infrastructure would probably also be a little bit challenged as well. But like I said, I think Ed's probably thought through some of this as well.
Yeah, no, I've got a few things there. So as we get further on, we'll talk about how to handle the long-term support release. Because we have examples of other communities in open source, Ubuntu being a classic, that the development community is used to moving extremely fast, way faster than an enterprise class user even wants to contemplate. And additionally, as we start looking at this, there are some increases in the support for releases because we're accumulating more releases more quickly. And so you also need to mitigate that. And so the mechanism that's been discussed in the mailing list for all of this is the long-term support release. So every third release is an LTS release, every 6 months, just like we do now. And that's the one that we turn to our customers and say, hey man, this is the one we're going to support long-term. It has the deeper tails to it, et cetera, et cetera. So that's kind of been the thing that's been discussed on the mailing list for dealing with some of what you're discussing there. Now, the thing for you, Jamo, in terms of your question of the mechanics of doing the release, there are a number of things about this plan that ease those issues, right? So to begin with, and apologies to all the developers in the room, but I write enough code I can say this, we can only get in so much trouble in 2 months, right? So because the amount of change is capped because we're moving more quickly, so too is the amount of instability that can be introduced. Additionally, intrinsic to this is that, for example, when you look at auto release, and I know Thon is auto release is up to how many hours now? So auto release is up to a 12-hour build, which is a lot. But if your auto release now is kernel auto release, where you've got 6 projects, protocols auto release, where you've got maybe 10 projects, and then apps auto release, which is still a fair number of projects, then the process becomes parallelized in a way that actually should make a lot of this easier rather than harder. Additionally, right now we have a process where we have about 5 milestones and a bunch of RCs in the process. And it's because we got 6 months to deal with, so a milestone every 4 weeks makes a certain amount of sense. And because we have so many projects trying to coordinate, across snapshots, you wind up with things like API freeze, code freeze, feature freeze. All the many milestone things that we report a lot out on are tied to points to try and help downstream cope with the rate of change from upstream. Not all of them, but quite a few of them. In the fast-phased approach, downstream doesn't have the same issues with coping with change from upstream because they're riding on release artifacts. Now, there are still some issues to be dealt with, and I'll talk about some of those as we get deeper into the slides.
So one more comment actually back to
Sure.
that question. I mean, we can actually theoretically we can adopt this this kind of a phased approach. At the same time, have the release like the where the apps are releasing. Have that stuff only every 6 months, meaning internally we can handle this way, but externally we can probably keep the 6-month cycle where, so this one will be called Boron 1, Boron 2, and...
yeah, and that's the idea with having the LTS support, and that's also the idea with calling the thing that comes out the far end with the apps being the overall Boron. So the time between people start working on Boron in kernel and overall Boron coming out is still 6 months. But when you get to the other end of that pipeline, Boron comes out. 2 months later, carbon comes out. 2 months later, nitrogen comes out. 2 months later, oxygen comes out. Okay, well, Boron is an LTS. Oxygen is an LTS. Make sense?
Yeah.
Cool. And then, of course, since we talked about what fast is and what phased is, and with pretty pictures, Boron. Explosions, green flames, just like I promised. Okay, so talking about advantages. So advantages of fast. So this means we have faster cycle times. It makes it easier to respond to changing needs. It also lowers the stakes of those responses. Because if I'm missing a release with a feature I need, it means a 2-month delay. That's a much less serious problem than a 6-month delay. It also makes it easier to keep up with non-open daylight upstreams. There have been a lot of places where we depend on various upstream things for features. OVS is the classic example in order to be able to do the things we want to do. And depending on where they release things that we would like for features in our cycle, it can be a very long wait between our release, between their release of the feature we need to support something we want to do, and when we actually get our release out. And we actually see things like this manifesting right now in the intense pressure to put features into stable releases, into SRs. And again, you lower the stakes, you make it much less attractive to do that, because if you need to get a feature out for real, 2 months, man. 2 months. And then the other thing that it means is, getting back to the point I was making about stability. Shorter time frames means less change for a particular release, means greater stability overall. no matter how much we like to do continuous integration and talk about continuous integration, there is a big testing push that happens at release. And not allowing as much space for people to get in trouble, at least in my experience, has massively improved quality and stability in projects that I've taken from long cycles to short agile cycles in my past history. So, advantages of phased. Obviously, the big one is downstream projects consume released artifacts, which means they're always getting what they got yesterday, except for when a new release comes out right after they push their release, in which case they upgrade to the new release artifacts. It also, as mentioned, allows you to break each group of projects into smaller chunks so that you get smaller chunks to work with, ease of coordination. It also allows you to federate some of the release management process. One could imagine, for example, somebody just looking after the kernel release. You do a great job, Anne. I'm not trying to push you out, but it's got to be getting heavy at this point. And so it provides a natural way to break the problem down into smaller pieces. It also means because we have shorter cycles, obviously we have fewer milestones, less reporting, less paperwork, etc. And a lot of that is meant to sort of keep us together so that we don't have downstream suffering because upstream is moving. And then, of course, the auto release being breakable into chunks so that you can actually spin it faster in parallel. So it's not all beautiful and wonderful and amazing. There are challenges. So to begin with, for challenges, there is integration of downstream projects against pre-release upstream. Right? So if a downstream project like protocols is consuming release artifacts from upstream, and upstream's master continues to do development, at some point in the future, upstream releases, downstream releases to the next set of release artifacts from upstream. We would rather that not be a big bang event with bodies strewn across the sidewalks. And so you need to have some way of detecting early and continuously that there may be an issue. I'll get into some of the ways we can deal with these issues shortly. Let me just catalog them. So you get to the long-term support question, which was exactly what Abhijit was asking Phil about, which is how quickly can our customers actually digest releases? And how long are we going to actually support these 2-month releases? 2-month releases means we're doing 6 releases a year. If I'm going to support the release till a year after it's out, that stacks up very quickly. This was actually something that was observed very early, and that's part of why we looked at LTS solutions. Stable branches. So basically, more simultaneous stable/branches that have to be maintained means a certain amount of overhead for maintaining them. If I'm kernel, I need to maintain the stable branch for Boron until, putting aside LTS issues for the moment, until after the overall Boron release goes out for some period of time, which means that I, in the process, cut stable carbon and eventually stable nitrogen before I finally fall off that edge. Version management. I've had a lot of conversations with Don about this. The current mechanism we use in auto release, which is the mechanism that we use for our version bump scripts, is kind of coarse. It looks around the world and it says, who here has the dash snapshot at the end of their version? Okay, great, we're going to move you ahead one. And it bumps that to release versions, and it puts a suffix on them that we know about. So that then, having cut the release versions, we can say, okay, who needs to actually go on to be a snapshot version again? Again, bump the versions, change the suffix. So it's all keyed off a version suffix. So in a world where we're doing fast phased, not all of the versions get bumped in the same way at the same time. When protocol Boron releases, that gets cut to protocol Boron for its versions. They get published, and then it needs to bump just the versions that it has from kernel away from Boron into the new carbon artifacts, and it needs to move just its own things to snapshot. So that is a difference, but I think it's actually relatively easily addressable. And then basically this gets to the point I was making about milestones. So we have 5, 6 milestones and some RCs in there. That's a lot to fit into a 2-month cycle. And since many of the purposes for which we have them are not as needful in a fast-paced world, that actually needs to be taken a look at as well. So any other questions here, challenges you guys think that have been overlooked?
We talked today about upgradability.
Yes.
So considering the long-term support, are we going to say that we are only supporting an upgrade path from one long-term release to another one, or are we going to say that we're also going to support upgradability between smaller releases?
So interestingly, I don't think that's actually been discussed yet in part of the conversations with this. So I can give my off-the-cuff what I would expect the answer to turn out to be, but there's not experience talking about it in the community to sort of say that there's even more than one person who agrees with this idea. And my sense would be that, yeah, you would primarily be looking at LTS releases being the ones that you take the serious sort of, okay, upgrade, support path, blah, 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 approaches to, because they're the ones you're supporting in the long term. So my guess is you probably just do it for LTS, but again, that's the off-the-cuff notion. It hasn't really been discussed yet. Others? Hang on, let's get you a mic.
What about features that require more than 2 months to complete, or migration efforts that require more than 2 months to have all 52 projects migrate in unison?
Mm-hmm. Yeah, so for features, well, number one, often, not 100% of the time, but often, you can actually break those things up into smaller pieces, and that will often result in better outcomes, because giant big bangs where you spend 6 months writing something and then you drop it at the end and say, we're done, that often produces suboptimal results, right? Now, in terms of forward motion for things, so there are a couple of ways you can look at the forward motion problem. If you're looking at migrating various things, and I've done a lot of this stuff, typically what it comes down to is marshalling a bunch of patches, dropping them in and testing them. I have definitely seen times where the discussion process about a migration takes longer than 2 months, unquestionably. I can't remember an instance where the mechanics of a migration took more than 2 months. Even fairly big things like the shift to Carafe were done much, much faster than that mechanically. Now, the conversations clearly can take longer than that. And actually, this gives us a better spacing. Because just taking, for example, the OpenFlow plugin migration, right? So there's a certain conversation going on right now about having that upgrade happen in an SR, which may be the way that we want to do it. But that's kind of a big change for an SR. But part of it is because there are driving needs for that migration to happen sooner than 6 months from now. Well, mechanically, and I've done these things before, so I can speak with a little experience, my guess is the mechanics of it are probably a couple weeks. The testing's probably another 3. So easy to do within 2 months. Now, of course, the discussion about it, the planning for it, that kind of stuff, that may very well take longer. And we've been talking about it in some cases for longer than that. But again, it's the pulling the trigger on the mechanics that really intersects with the timeline for the releases. Others? So the question, so what we had was Anil just tossing the term up at me, API deprecation. Which I think what you're basically getting at, Anil, is traditionally the process has been for deprecating an API is you deprecate it in one release. And then, so if I were to deprecate an API, say in helium, I got to keep it around for lithium. I can delete it in beryllium. And that's typically been the way the cycle has gone. Again, I don't think there's been a huge amount of discussion around this. So take this as one man's idea. But my notion is mostly what we're really saying is that in addition to the fact you need a cycle, that you don't want to have APIs appearing and disappearing too quickly. And so my gut suggestion would be to suggest that we move API deprecation and deletion to the LTS cycle rather than to a 2-month turn. But that's just one man's thoughts. Yeah, in the LTS release. Yeah. Yeah. We've got Colin looking for a mic.
So there's a. Now I've lost my train of thought.
I have great confidence you'll get it back.
Somebody else go.
No, we are waiting for you to collect your thoughts.
So Is there anyone else who has something before I move on to the next slide? Anil, you have another? I didn't hear you, what? I have a slide. That's a very good question, and I have a possibly too large and too colorful slide for it, but give me a few. But that gets to the stable branches challenge.
Is what happens when projects don't want to participate in every release?
Mm-hmm. Right.
So right now at 6 months, essentially every project is willing to take on releasing every 6 months. There are lots and lots of people in the community that aren't full-time, and it's important to recognize that like 6 months gives them a way to do other things and still meaningfully participate in the simultaneous release. Doing that 3 times or 6 times a year is going to make that much less tenable, which means you need to have a solution for them to be able to have meaningfully belong to Open Daylight without participating in every release. LTS has fixed some of that, but potentially not all of it.
Mm-hmm. Well, and I think it also depends very much on where you stand as a project. And there's, one has to sort of distinguish between, because clearly we don't have any capacity to make a project participate in a simultaneous release. So I'm not suggesting that we do that in any way, shape, or form when I say this. But when you look, for example, at the kernel projects, they tend to have folks who are in a position to work on getting a release out every 2 months. This tends to be true for most protocol projects, not necessarily all of them, but most of them, and particularly the ones that people are very anxious to consume, the ones that have a lot of downstream consumers, tend to also have fairly dedicated participants.
That's objectively false.
Which one?
OpenFlow plugin has sputtering progress. I mean, they do lots of really amazing things,
Mm-hmm.
but there are months at a time where nobody does anything.
True.
True.
Yeah, no, true. But the question becomes, so there are 2 things that go into this. The first thing is, if you are a project that actually doesn't change a lot in the course of a release. Let me give you an example. TCP MD5 sum is a good example of this. So TCP MD5 sum objectively is almost moribund, but that's because it is objectively almost entirely feature complete. It does the thing it does. It does it reasonably well. And so I think that actually gets to sort of the underlying thing, which is if you look at the fast phased, what it really comes down to is what release artifacts you consume. And so if you consume the last release artifacts from a project, then your worst case scenario, if that project doesn't participate in the next release, is you continue to consume the last release artifacts from that project, which means that things get no better, but they also get no worse.
Assuming you don't depend on newer versions of their dependencies.
In terms of, you mean in terms of third-party dependencies? Or in terms of other internal dependencies to Open Daylight? Yes, no, I see your point.
So you're right as long as you don't depend on older versions or newer versions of their dependencies. So if they depend on MDSAL 1.1 and you depend on MDSAL 1.3, you're SOL.
True, but essentially that comes down to a version bump issue, which I think we're already doing automatically anyway, correct?
Well, assuming that there's no meaningful change.
Right, yeah.
Which is also...
But again, if there's no meaningful change and there's no participation, we have other problems.
Well, no. Assuming there's no meaningful change in the bump of the dependency that they have. So if MDSAL changes an API and they are not present in order to consume that API, but you want to use them, you have to somebody has to go do the work for them, or they have to show up.
So given the fact that we're talking about having LTS releases and having the deprecate delete cycle follow LTS releases, we're actually, I think, no different than we are today, which is if you will wander away for 6 months such that the underlying APIs that you're consuming get deleted out from under you, it's just as if you wandered away for 6 months now and your underlying APIs got deleted out from under you. So there was a whole question that Anil asked about how long the deprecate delete cycle would be, and the suggestion was that you handle the deprecate delete cycle instead of deprecate one release, delete the next, as deprecate one LTS, delete the next after the next LTS, which puts us on the same timeline.
And that's assuming that we actually are really, truly honest about backwards compatibility with their APIs, which we have utterly failed to be so far.
Okay. The what process? That
He's saying
actually
to drop
introduces
the
all kinds of
release-based
other
version
issues.
bumping.
Right. I said, so Ed hasn't started talking about his solutions to the challenges he's listed here, but I would argue that we should, I'd argue that we should drop the release-based version bumping process. And so typically TCP MD5 would be version whatever and just stay at that version.
So and the place you run into there, again, gets back to the dependency tree thing that Colin brought up, which is if I am the SNMP plugin version 1.1, and I depend on the MDSAL version 1.0, and I haven't really made any appreciable changes, but we get to a release, if I don't bump my dependencies and my versions, then I'm pulling MDSAL 1.0 in when everybody else is pulling MDSAL 1.1 in. And that produces issues.
Well, not if you use ranges or if... So for TCP MD5 is simple enough that it shouldn't have any dependencies. And
I agree with you, TCP MD5 is a particular case. No, I agree with you.
And anything else...
Do we have the technology to use ranges right now in Open Daylight?
Not for Yang, but for most other things, probably.
For
yes.
features?
For features, yes.
Okay.
For jars as well.
Okay, no, that's good to know. I wasn't looking at all that much change all at once. I was looking for the smallest, simplest change to move us forward. So, challenges. The integration challenge that I'd mentioned, which is how do we make sure that we find out soon and do something about it when upstream does something in their master that is going to break downstream. So the good news is we have almost the entirety of the solution in hand already, in that we have integration jobs that run. And the way the integration jobs work today is if I'm a downstream project and an upstream project makes a commit, it should trigger my integration job, which then tries to rebuild me and rerun whatever my tests are locally, to make sure that whatever upstream just committed, if it broke me, that we find out as soon as possible that it broke me. Now, there's one change that would have to happen here, because what's actually in my code base as a downstream project is not actually the snapshot artifacts that are coming from upstream. So your integration job would have to change in one slight way, which is that as part of the prep to do the build in the job, the versions would have to be bumped back to the next snapshots. But then you would rebuild. And at that point, your integration jobs tell you, okay, a patch came into upstream, I rebuilt what I have on my master against what upstream just published as artifacts. Did everything blow up? And so you can say, okay, great, is my integration job healthy? Is my integration job not healthy? If my integration job is not healthy, I need to go investigate why, probably or possibly complain to upstream, and get it resolved. But unlike the situation today, where if my integration job is unhealthy, suddenly I'm blocked on my master, in fast-paced, I'm no longer blocked on my master. So if I'm sitting here on a Monday afternoon and I'm desperately trying to get a feature done for Wednesday, for whatever reason, maybe I'm about to go on vacation, I can say, okay, I'm going to finish the feature I'm working on master, drop an email out and let folks know. We'll take a look at it, and if it takes 4 or 5 days to go sort out what's going on and fix it upstream in master, nobody downstream's blocked. So you have a lot less panic fire drills than we do right now when something goes bump in the night. Now there's a flip side here to the responsibility, however. If I'm a downstream project and I'm in week 2 of my cycle and my integration job breaks, meaning that I now know there's something going on upstream that I'm going to have a problem with 6 weeks from now when upstream releases. I really should, at some reasonable point, let upstream know so that we can get this sorted out, so that we don't wind up 6 weeks from now going, oh crap, I'm broken, when it's been known for 6 weeks and nothing's been done to sort of marshal folks to go deal with it. So that's the basic idea behind using the existing integration mechanisms with a very small tweak to be able to allow us to identify, hey, we have breakage, but in a way that doesn't put us where we are today with our hair on fire.
So there's one thing here which I think is a little bit, it needs to be noted, which is this effectively, what you just said throws a lot of the things that we avoided by being phased back into things, which is now I have an event stream, which is the same event stream that was causing me pain before, which was that things break and I need to fix them. The only thing which I've changed is that I've made it so that way I can continue to do other work and maybe realign when it is that I'm going to fix it later to some other time. But it does mean that I now still have an event stream of I'm broken, and I need to go poke somebody and track it down and deal with it, which is a non-trivial fraction of the pain of our, of our snapshot-based integration. So this solution drags back in some significant fraction of the pain of snapshot integration.
Yeah, so there's a certain law of gravity effect here, right? And the law of gravity effect is that if change occurs upstream, that is going to produce a problem downstream. And quite honestly, sometimes those problems downstream are just the revelation of existing bugs downstream. So it's not, the problem event occurs is agnostic as to whose fault it is. All we know is an event occurred, and now we know we have a problem. The real complaint that I have consistently heard from people about the process of things going bump in the night is the complete lack of control that they have over their circumstances. So I can't continue moving forward and working because I'm broken, because something happened and I haven't figured out what's going on. I have no capacity to decide on what reasonable time frame I'm going to deal with it because everything is stuck now. What this actually does is it restores a lot of that control into the hands of downstream.
Actually, the concrete complaint I've heard is I can't roll back. If I could just roll back, that would be my problem. That solves my problem. The problem that I've heard, and I don't know, Brady, you can tell me which end, since you've been hit by a lot of this, whether it's that you don't want to deal with it now, you'll be making progress, and this fix sounds better, or the thing I've heard is I actually know kind of what's wrong. I know I need to go back a couple of patches in my dependent projects. There's just no good way to roll back to a consistent point across the different projects in a snapshot because we don't have that data. I'm not going to.
Yeah, I would tend to say, Colin, that basically what you're expressing is the typical engineer tendency of proposing a solution to a problem instead of discussing the problem, right? Which is one solution to the problem is if I could only roll back to yesterday where everything looked like it was okay, then I would be happy again. What I'm saying is the underlying problem is you have no freaking control at all. Right? And so you're just stuck with the event smacking you in the head with no ability to manage anything about it. Now, would rolling back give you some mechanism to manage it? Sure. But we've been talking for at least a year and a half, I think maybe 2 years, about continuous release mechanisms that would allow you to roll back, and they've not happened. Go ahead.
Yeah, I like the approach. I like this that, I have something stable, it's not a moving target. I can see that there's some extra overhead. And what if I'm crazy busy on my 2-month cycle and then something breaks in the next one? I don't have the cycles to put into that. That's an issue. But, I mean, if doing the rollbacks is something we can't get or it's going to be, I don't know, really complicated.
Yeah, I'm not saying rollbacks are impossible.
No, yeah.
All I'm saying is we've been talking about them for 2 years and they haven't happened. So
yeah, rollbacks would be awesome. And a way to do that, perhaps we could have, I don't know, in this 2-month or 6-month cycle, have very short little, every 2 weeks, some sort of even just a tag or something, a git tag, but I don't know how feasible that would be.
Yeah, I mean, in some sense, this whole notion of fast-phased arose out of frustration with the fact that we couldn't actually get to continuous release after having spent basically a year and a half, 2 years talking about it, and looking at what we probably conceivably could do in a relatively straightforward way. Anything else on integration challenges? Okay, stable branches. Upstream projects would have to have more stable branches, and I actually have a picture in here somewhere. I don't know why I didn't quite make it to this slide. So the proposal is stable branches are kept until after the downstream, so putting aside LTS for the moment, stable branches are kept until after the until after the release after the overall release. So
that's
if I
actually, they're kept until the release after for security issues.
Branches are easy to keep around. Let me move forward and we'll talk about LTS as well, right? So the basic notion here is that if I'm kernel and I release Boron, I cut a stable branch. Meanwhile, protocol releases Boron. Meanwhile, I've released carbon, so I've got stable boron and stable carbon. Actually, let me find my picture. Picture. So, no, I've done all I can in that department. So basically, and this actually shows some of the phase-in as well. So you get a stable branch that gets cut in purple for boron. You get a stable branch that gets cut in blue for carbon. You get a stable branch that gets cut in orange for the next release and so on. And you basically keep the stable branch around until app's version of things, until app's boron has reached the end, because apps has done the release after boron, which is nitrogen, I believe. So you end up keeping roughly, if you're kernel, you keep roughly 3 extra branches, not counting LTS. If your protocols, you keep roughly 2 branches, 2 stable branches, not counting LTS. And if your apps stable branches don't really look all that much different for you when you take out the LTS aspect of it, because you don't have any downstream that you're keeping them around for. So there is a certain amount of tax on the upstream projects in terms of having additional branches to keep. Part of what they get as a benefit there is if someone shows up saying, "Oh my God, you broke me." One acceptable answer is, dude, it's a national holiday on Monday where I happen to live. Can I get to it on Tuesday? Which is not such a great answer right now if you are currently living in a snapshot world. And so, yes, there are more stable branches to keep track of, but you also have, again, more time, space, and control over how you actually deal with crises. So that's basically the notion with stable branches. Do we have questions about stable branches before we move on to version management? Anil, you really need a mic.
What about the SRs? We have a stable, but then we do the SR, right? SR1, SR2. How many SR we are going to keep, right?
So the notion that's been discussed, and there's actually a fast-phased boron plan that actually spells this all out in complete detail, is during the period when you are supporting a release for the benefit of your downstream consumers, right? So I'm kernel. For the next 4 months, my downstream consumers are going to be getting stable releases for their benefit, right? During that period, you for example, if you've got a 2-month cycle, you do an SR at 4 weeks, and 4 weeks, and 4 weeks. Because if there's a downstream project that, discovers a bug that you need to have fixed, you need to fix that bug and get it to them in a relatively timely manner. Now, hopefully we're not talking about catastrophic bugs. That's the purpose of the integration process, to catch as catastrophic bugs. But we all know, sadly, not all bugs are catastrophic. So I'm 2nd-generation software. I'm a coder like my father before me. And so I can remember being this tall and having my father explain to me the worst thing code could ever do is run. And sometimes that's true in the case of stuff where, gee, it runs kind of, it runs mostly, but you hit a corner case bug that isn't necessarily caught by your testing and build in the integration. And we'll hit those, no question. And so you have to have an SR process that has closer spacing when that's happening so that you can get an SR in a timely manner. So that's the current thinking about SRs. And then when you get to LTS releases, where you're past the point where you're there basically for the benefit of your downstream consumer, then you move to the more traditional 6-week time frame that we talk about for SRs.
So about the stable branches and the SRs, I really think we should just limit these stable branches for what you call the long-term LTS as opposed to the internal releases.
Okay.
Because it does have an overhead. It does have. I mean, why do we want it for each of the individual internal releases?
Well, so the question I would ask then, and it may just be that I've expressed myself poorly, is say that I am a protocol project, right? And I've got my integration branch going. My integration job has told me that everything's fine. I dig in, I start doing some development. I'm actually really excited because there's a new feature I want to try and use. And I start developing against it, and I discover there's a bug. Where do I put the fix for that bug? And by what mechanism do I get that bug from the upstream grouping?
Yeah, just a comment. I think in your situation, you need to support the stable just for the next one, just until the next release. It's the idea, no? To support the stable just for one cycle, 2 months, and that's it. Then you drop, and then you.
So I think you have to support it for 2 cycles at least, because if I'm kernel, or at least as far out as your downstream consumers, if I'm kernel and I release Boron, then protocols is going to work on it for the next, based on that for the next 2 months, and then the 2 months after that, I'm going to have apps working on it. So if your protocol,
Yeah, protocol.
so your protocol, so here you sit, you would need to cut a stable branch and keep it for the time that, at least the time that you've got apps working on it, in case the apps discover that you have a bug that you need to do an SR for. Does that make sense? You can argue about whether and how long you should have tails past that originally 2-month period, but at the very least, you owe your downstream a bug fix while they're trying to do their initial build on top of what you've given them, even in the non-LTS case. Does that make sense? The LTS, the SRs, yeah.
I mean, this might make sense for, but as far as SRs, I think where we are doing the formal SRs, like lithium SR or beryllium SR1, I think that should be kept to the LTS.
So again, the question becomes, if an app finds a bug in OpenFlow plugin,
then of course you fix it. Yes.
Okay, so are you suggesting basically doing a per bug fix release rather than an SR based on time? Because the downstream is consuming a release artifact, right?
It's. I mean, I'm just worried a little bit about having too many of these. The formal SRs. So that's where I'm more.
No, I understand, and I'm not here to shove it down your throat. I'm just sort of thinking that for a downstream consumer from a protocol project, if you find a bug, you want some way to get that bug within the scope of the cycle that you're currently doing development on. And there are ways you could do it. Like I can think of at least 2. One is you have a scheduled SR, and the other is that if you have a bug reported, you fix it, you do an unscheduled SR, right? And you could certainly have discussions as to which one is a better approach to the problem. I had originally been thinking, and this was maybe a false thought on my part, that the projects would find it more comfortable to have a scheduled SR to bundle up whatever bugs and get them out the door. But I'm willing to be told differently.
Yeah, so possibly. I mean, yeah, you could have this, the scheduled SRs for your consumers, meaning for the downstream projects, for your downstream projects, rather than.
Oh, okay. Yeah. No, that's fine. I mean, I think what you're just saying is you'd like less overhead on getting that SR out the door.
Yes.
And that makes a lot of sense. I misunderstood.
Where An is involved, where like the rest of the.
But An's a really nice guy. Yeah.
So at this kernel project.
Depend on the severity of the bug. What? The SR timing could also depend on the severity of the bug. So if it stops me in doing useful work, sort of a blocker bug, then we could have like an instant SR. No, if it's just lower severity bug, then we can just have the schedule.
Yeah, no, it's entirely possible. Yep. Cool. So
I have one more question.
Yes.
So when, let's say application using kernel project and there is some bug in a kernel project and you fix it, and kernel project is already released. Okay, we are using the released version of it. Now we'll fix that bug in the kernel project, but are we going to kind of publish a new artifact with the same version number, or how they are going to consume this new bug fix that happened in the?
So, our release versions in Maven are a promise. And that promise is, if I give you a release artifact ID, group ID, release version, and possibly classifier and type, but let's not get distracted, I will get back exactly the same fricking bits every time.
Yeah, that's what I'm saying. If that's the promise, then you kind of put new fixes in there, because
So the idea had been, and I'm not saying it's the right idea, but the idea had been that that's why you would have more frequent SRs during the period where somebody is starting to consume what has been released. So rather than saying, okay, we do our release, you pick it up, you start doing work against it, you find a bug, right? So there's a scheduled SR 4 weeks after the release for the purpose of your downstream consumers.
No, that I agree, but
Yeah.
you know how the SR will come out, but the point is the bug is fixed now. I'm just thinking about, as of now, in a master we have a snapshot, which we can just download it, use it, and we get the fix immediately, right? But if in the case where app is kind of waiting for a kernel release version, or they have to wait for a SR for that, because they want to do a daily development, right? They want to fix.
So what you're basically saying is, can I as a project say, to hell with it, I'm going to take the stable branch snapshot for a little while?
That's what I want to say. Because for them, it's going to be a kernel master, right? Because if you're putting a fixes in there, you need it immediately so that you can unblock yourself, right?
So I mean, I would suggest, from my point of view, there would be two pieces to the answer. So from my point of view, number one, I can't see any reason why anybody should be able to tell the project it can't, right? As long as they get back on a stable release for the actual release when it comes out. And then the second thing is, it's probably not even that terribly inadvisable for a brief window of a couple of weeks. Your additional exposure becomes that if there is some other bug fix on that SR that does create a problem for you, you might have a hair on fire kind of incident. But that's relatively, I suspect that to be relatively low probability if we're actually just doing bug fixes on our stable branches instead of introducing new features. Not impossible, right? You know, life is full of trade-offs and you take your risks, but
And in case of SRs, we have, let's say we have, 4 weeks of SR. And hopefully we just have one. If you are going to have more than one, there is a dependency problem also there, right? Some of the consumer application are kind of consuming SR1 of that.
No, you're right, because you may be consuming features that depend on other kernel features that are on release versions. So that mechanically probably wouldn't work. You're correct.
Practically, you want to freeze the upstream development for the 2 months or 4 months that follow, so the downstream.
Yeah, well, the downstream would really ideally like to never have that artifact change under them
You could
until they get to a release.
Still leave it as a snapshot. Everyone just accepts that this branch is frozen, and we only modify it if the downstream 2 month, 4 month needs a bug fix, and they probably want it today if they need it. Leave it snapshot. You don't have to go through any release.
I mean, so
gyrations.
I get what you're saying. I don't think every bug is a hair on fire bug. I don't think every bug is one, and you do want to get those bugs into stable as soon as those bug fixes into stable as soon as you can. Like, I'll give you an example. Oh crap, we fucked up. We're slightly log flooding, not untractably log flooding, but slightly log flooding in a way that's really inconvenient for the integration guys. It's really making their life hard. Is that a bug where you necessarily want to cut an immediate emergency release? For the sake of argument, let's say no, right? But you'd like to fix it as soon as you can so you don't forget about it. So I think the real key part is I think this is what you're getting at, is making the stable branches just about actual bug fixes and not about feature work.
Right.
And we've historically been really bad about that because the long time that we take to release has put an enormous amount of pressure to do feature work on SRs. And the hope is that by shortening that time cycle, the pressure to do feature works on SRs mostly goes away.
Yeah, I'd suggest that you call this phased freezes. We're still releasing every 6 months to the external world, to the consumer. They're not going to get a release any more often, but the development of offset 1 and 2 gets the benefit of a stable upstream.
Yeah, but essentially, what you can't do is you can't tell upstream kernels they can't do any work for 4 months out of every 6, right? So they've got to be able to keep moving forward in phase.
Oh yeah, I love your plan. I think we get in trouble when we call. If the picture were up, it might help. But the first 2 month effort of offset 0, or
is this? Do you want the branch picture or this picture?
Yeah, this picture. So the kernel has done 2 months of development, and effectively, that's all the kernel work that's planned and executed, other than bug fixes
for Boron
for the 6 month release.
Well, for Boron,
yeah, which is a 6 month release.
Well, Boron, it may be an LTS, right? But the thing is, then Carbon kicks in, and Carbon will release overall Carbon will come out 2 months after overall Boron. Right?
Right. But the kernel work for Carbon happened at the beginning of the 6-month cycle.
Yeah, no, I just wanted to make sure we were still talking the same thing. Yeah. So basically, kernel has long since finished its non-bug fix work for Boron.
But rather than get into the overhead of having service releases against an early, official release of the kernel, leave the kernel snapshot on a branch that no one develops on unless...
That is an interesting idea. So did everyone follow what Greg was just suggesting? Okay. Here was Greg's suggestion. And it's an interesting suggestion because it may solve some of this problem. In fact, I feel slightly stupid. It didn't occur to me. So Greg was basically saying, and this actually should make a lot of things quite a bit easier. He basically said, listen, so kernel works on Boron for the first 2 months. And rather than cutting kernel's release Boron artifacts at the end of that 2 months, you go and you cut snapshots for kernel at that point, and you pull the stable branch. And the kernel snapshots will only ever come from the stable branch. And the only thing that ever goes into the stable branch are bug fixes, which means the only time that snapshot moves is if somebody is fixing a bug that somebody has complained about. And so effectively, in this case, let's say you're sitting downstream in NetVert, and you discover there's a corner case in the OpenFlow plugin. Now, you're getting things that are formally snapshot releases, but they're not shifting except to fix bugs. So you go back to Abhijit and you say, Abhijit, you have a bug. Right. So people go work on it and fix it, and that shifts. Now, there's a certain trade-off here. There are always trade-offs, in that you do have a certain amount of risk that if you bork that bug fix, now you've actually set everyone's hair on fire. But the idea would be these snapshots would change very infrequently because you're only doing bug fixes against them. But you would be able to take advantage of those bug fixes. Did I just completely lose everyone? Yeah, pass a mic.
Thank you. All right, so the only thing with snapshots, so having gone through this experience, the thing you have to be careful with snapshots is that you potentially reduce or eliminate the repeatability of your builds. And so it makes it really difficult to say, hey, this is the exact version that we were running. Can you go repeat this environment somewhere or repeat what a customer is currently running? And one of the things that we can do with either Maven or Ivy is that we can actually specify ranges saying, please pull the latest version of this and the latest patch version of this. And I would argue that it would be better to leave the snapshots for development for people to test. And when we do a bug fix, to explicitly increase the patch number of or whatever we're using for that, and use that to perform the increment and allow people to upgrade from there. And primarily because when you start working with snapshots, then you start to get, it becomes much more difficult to get that to get that repeatability.
Okay, that's a good point. I mean, one other possibility, yeah. So that's definitely a good point. So I think what you're basically suggesting is that we basically use Maven version ranges that would pick up any new releases on that particular stable branch when we're talking about downstreams?
Yeah, and to leave the snapshot, like snapshot is still a good idea to have, but that would allow people to stage and test, like, did we actually fix the problem, go test against a snapshot, and then when you cut an actual bug fix that's as part of the release, and then you would just go to that specific version. So and I think that would give a good mix where we solve the underlying problem, which is we need to have the ability to test fixes and so on, but at the same time not destroy users who are running this in a production mode because they were tracking snapshot by design. Okay,
good thoughts. Yeah. Do other folks have comments? Okay. So, I mean, that's actually a good, those are both good ideas to sort of put into the hopper on this. So, we talked about advantages, challenges, integration challenge, stable branches, long-term support. I think we've actually talked a lot about long-term support before we even got to this slide. Is there other things that people would like to talk about around LTS releases? Okay. Yes. Go. Anil? Mike.
So at one point of time, we are just saying that only one long-term support is going to be there, or there can be two. How we are planning to do it is.
So basically, effectively what we're talking about with long-term support is every third release, we treat in terms of the longevity of support the way we currently treat releases.
Mm-hmm.
Right, so that you have long-term support. So it's not trying to chase everything for that long a period of time. And this also gives you the one we will actually look after long-term to point your customers to. Very similar to what Ubuntu does, where Ubuntu keeps marching really fast, but every now and again they come up and say, okay, it's a long-term support release. This one will actually support in the long term. So that if you're an enterprise consumer, you have one you can grab and get longer-term support for.
Mm-hmm. Okay.
In the same lines, actually, I asked the question before. What about the multi-version upgrades? That's very much.
By multi-version upgrades, you mean basically what happens if I upgrade between LTS 1 and LTS 3?
Right. Right.
So I think that roughly becomes an orthogonal problem, in that we have we have an understood upgrade problem. I don't know if it gets worse in this way. Can you see ways in which this would make it worse?
So I think there's two questions. One of them is so the question is if you have boron, carbon, and nitrogen, and then what comes after that?
Oxygen.
Oxygen. So you want to upgrade from boron to oxygen?
Yes.
Which is LTS to LTS, assuming boron is an LTS. So it's 3 apart.
I'm presuming boron and oxygen are the LTSs.
You have
both highly volatile.
You have lots of you now have the problem you now have 3 different. It's potentially more complicated to the upgrade because you've made sort of 3 small changes, and you either have small things to upgrade in between those, which probably you need for testing in general, working around with things, and then you have to either compose those 3 upgrades or invent an entirely new upgrade system that goes from 1 to 3, and that's assuming that you're willing to live with just LTS to LTS. If you want to do LTS 1 to LTS 3, which is I'm not sure that's actually what you were asking, even though that but that gets even that same problem is true recursively if you want to jump over longer LTSs, and so I don't think it strictly makes this harder, but it certainly, if you want, I think a reasonable person would want upgrades between individual releases, adjacent releases, and between LTSs, and that joint problem is certainly more complicated than merely solving the adjacent release problem.
So my gut instinct would be that the upgrade problem mostly, not 100%, mostly has to do with the volume of change between the 2 points in which you would like to upgrade. And my gut is that if you've got a 6-month period where it's just 3 2-month releases and you hit the next LTS, that you've had 6 months worth of change. And if you have one release that goes across an entire 6 months, you have 6 months of change. And so I'm not going to stand here and make the claim that that's 100% the same, but my guess is it's about 90% the same problem.
So I think that's true if you don't want to allow people to upgrade directly from boron to oxygen. If you're willing to make people go through the process of boron to carbon to nitrogen to oxygen, then you have one single upgrade path. That's true. So if you're willing to say that either you're willing to go through 3 of them, or you're willing to tolerate not having upgrades between adjacent releases, so you don't need an upgrade process from boron to carbon, then I agree. Otherwise, I think, so if you don't do one of those 2 things, either give up adjacent release upgrades or force people to go through a lot of different points on the space, you have to have 2 upgrade paths. And the cost of testing and implementing 2 upgrade paths will be higher.
Fair. So, again, I tried to make this as small as I could, but this is the best I could do on the branching diagram. Version management. I had conversations with Thon about this, and this gets down to the fact that the existing scripts we have are really coarse in terms of how they bump versions. This actually doesn't surprise me because I think they started with the original auto-release scripts, which were very coarse in how they bumped versions, and then they got really smart when they got into the hands of competent people like Thon. But there are actually tools we can use. It turns out, thus far, looking at the problem, that the dependency versions you need to upgrade tend to be represented most of the time either with things that are pulled in from parents, or, for example, for kernel, we have artifacts that can be pulling in those versions. For the kernel pieces, we have artifact. And so I think you wind up with a fairly finite list of things where you know the group ID, artifact ID, and the version you need to get to. So using some of the Python XML support or something like XML Starlet, it should be entirely doable to write a script that actually will step you forward in these. And in fact, I was just talking to Thon, it's actually probably entirely doable to run a nightly job to extract the versions from various branches of upstream that you should be using when you run that script. Yes?
Why not just work on our artifact versions that have the release name in them? I'll repeat the question. Why not just give up on using version numbers with the release name in them, and identify a release in some other way?
So that's certainly a valid conversation to have. It might be useful to explain why we have release names in our versions for our release artifacts. And it comes down to the current mechanism that's used for doing the builds and bumping the versions and putting things back the way we found them on new snapshots, which is that the way when we bump to a release version for things in auto release, we look for all the snapshots and we replace dash snapshot with dash the version name to make it a release artifact. This ends up being a very, very straightforward heuristic. Really easy to implement and relatively stable. It also has the nice side effect that it catches you when somebody has tried to depend on a snapshot artifact from a third-party source, because it blows up. And then when we go to do version bumps, we basically do the same thing on the branch for the version bump. We apply the patch for that. And then when we try and go to the next version of a snapshot, the way we figure out which release artifacts should have their Y value bumped and then go to a snapshot is we look for that suffix. Now, I'm not saying this is the best way to do it, we couldn't do it better, et cetera. And in fact, moving to somewhat more sophisticated tools gives us an opportunity to revisit some of this decision. But that's the reason why it happens to be this way at this time.
Right, because usually in the Maven world, releases are done using a Maven tool that's called release, release, and it handles things like that.
As God is my witness, the hydrogen release process will never happen again.
Yeah, but that's because you're cascading lots of snapshot releases using that. But
so we discovered when we went to release hydrogen, this was long, long ago, we discovered that the Maven release plugin is extremely fragile to a large number of things that you can do in POM files. So if you haven't been extremely scrupulous about keeping those things out of your POM files, it fails radically when you try and actually do the upgrade. We spent, what was it, do you remember, Luis? We spent like something like 18 hours together as a community on an IRC channel trying to cut 6 projects or 7 projects for hydrogen. And that's 100% of the reason why we moved to the auto release process in Helium, because we, and that's why I said what I said, because I literally swore that day, as God is my witness, we will never do this way again, right? Not so much the version release, but we're never gonna have this 18-hour monstrosity. So there's this historical extremely bad experience with the Maven release plugin not actually doing what we were hoping it was gonna do for us. Doesn't say it can't be revisited and discover that actually, things have cleared up, we're doing less stupid shit, it's actually much more workable, or the plugin itself has gotten more stable. But just to understand the historical reason why we're not just merrily traipsing along with that plugin. And in fairness, I think it was mostly because we were doing deeply inadvisable things in our POM files.
Yeah, I'd imagine that would play into it. But isn't there, Thon, well, would it be possible, isn't there an issue with uploading our artifacts to Maven Central if we use versions as we currently do? No?
I'm pretty sure .NETty is up in Maven Central, right? And they use a -final suffix.
Dot final.
I thought it was -final, but maybe I'm misremembering.
Dots.
Okay. Yeah.
But because, right, Yeah, well.
We should figure it out either way, because I'm a huge advocate of getting our stuff into Maven Central.
Ed, there may be a simple and quick answer to this, but do we have any scenarios where we have interplay between applications and protocols such that, you know, an application needs to do something in the config data store and the protocol needs to do something in the operational data store where we get a catch-22 between the phases? Does such a thing exist, or is that got an easy workaround?
Let me try and rephrase your question. Is there some scenario where we have a cycle between protocols and applications where an application project depends on a protocol and a protocol project depends on an application? I'm sorry,
particularly in new feature creation, right? So, and do we run into any problems there with doing this phased approach where you can't get one done without the other already being there, or what does that look like?
So I can never say never, but my gut reaction is that such a scenario would be pathological and a sign that something really terrible had happened. And so I would almost be tempted to say, you know, yeah, Abhishek, you have you.
I think what Phil is referring to is a possible situation where you need a simultaneous development. In a simultaneous development for achieving a particular thing in a kernel project at the same time as in protocol project and an application project.
Do you have a concrete example in mind?
So a concrete example would be the way OpenFlow plugin development used to happen before, where you had some things happening in the controller, some things happening in the OpenFlow plugin, and some things happening in the OpenFlow Java.
So would it be fair of me to say that was pathological? and that a scenario that would have prevented that from being the way it was done would be good?
But I think that's kind of a situation that Phil is talking about.
And I guess my response would be, it strikes me as, I remember that situation well. You may recall I was trying to shove the rock up the hill at that particular time, and it was quite a mess. And I would go so far as to say it was definitely pathological, that situation, and I would consider it to be a feature, not a bug, of the new system, that it would be harder to dig that kind of hole in the future. Because what you really had there was a smearing of a protocol across two projects in a way that it shouldn't have been smeared.
Across three.
That's true. You could make a defensible case for the smear the other direction. You know, there was at least a consistent dependency piece there. But no, I would agree with you. You basically, you had quite a mess there, and I would consider it to be a feature that it would be hard to reintroduce something that bad.
But would that be a situation for any other grouping of projects where you require multiple projects in different lifestyle, different offsets or different groupings? I mean, that's one thing we don't have to think about it right now.
I was going to say, can you think of possible examples? Because, I mean, I'm not saying such examples don't exist, but I couldn't think of any off the top of my head. Other than that one.
So that's what I cannot think of any right now.
Yeah.
Or, and I may not be the right person to think of all possible things like this. But
what about Lux? Go ahead.
So if you're talking about cycles between phases, Deluxe would be the example that is everybody's worst nightmare, and it's a pathological case, and it can be fixed, but fixing it is non-trivial, which is that almost everybody wants to have Deluxe packaged in their local distribution, so that way they can test stuff with a nice GUI. And then Deluxe wants to pull in almost everybody to be able to render their content into the universal nice new GUI. And the result is everything goes there.
Yeah, and that needs to be changed such that Deluxe provides a core which everybody relies on for their particular plugin, and we invert the dependency and everybody's happy.
Process check. We have chewed through the break and we have 5 minutes to get cookies before the next session.
Okay. Anything urgent enough to delay cookies? Because basically, from my point of view, the last thing I wanted to do, and the milestone challenges we've talked about, is the sort of getting here now, which is basically, we actually can start getting here at this point. The kernel project can start with a 2-month release plan. We can work out the scripts in the next few weeks in order to be able to handle the version bumping for the mechanics. Now, please note, for a 2-month release plan, you'd be looking at a 3/17/M0 date and a 5/12 release date for kernel. And then you can proceed from there, and you can see sort of the way the dates cascade through protocols and apps in terms of that stuff going. So this is actually quite doable at this point. And the only sort of loose end, I think, is needing to get the version bumping scripts done. And having poked at those a little bit during other people's talks, I think that's a pretty doable thing. And I'd like to see us actually have that done and tested by 4/12 so that we actually know we've got our forward path in place. Do other folks, Stephen? Not necessarily. You actually have a choice. Right. The choice you get to make about how you phase this in is, yes, you could revert offsets 1 and 2, protocols and apps to beryllium release, or you could just start where we're at and switch them to release artifacts as new release artifacts come out. There's a choice point there. What? That's my gut feeling, but hey, I'm just one guy.
Participating in all releases? Or LTS?
So my expectation is documentation is a lot like everything else. If you do it in smaller chunks, it gets easier. And so I would anticipate wanting to say, okay, when you do your Boron release kernel, you need to actually have documentation for Boron. But I would expect that there would be a much smaller delta from what you did for beryllium because you haven't had as much chance to do stuff. Ryan?
Yeah, I have a question based on some real-world experience that I had with Open Daylight.
Sure.
Is sometimes, you change something in offset 0 and you don't realize the implications that it's going to have on downstream consumers. So when
Are you implying that you've done this?
When I swapped out, Jersey 1 to go to Jersey 2, I didn't realize that you could not include Jersey 1 whatsoever. And a nice feature of our current system is that pretty much everybody told me right away that I did something wrong. And my fear is this gives us a lot of time in between me possibly committing something like that and somebody from an offset 1 project consuming it. So much that I might not even be able to revert it for them.
Yeah. Well, I mean, and this is actually why the integration process is important, is that hopefully that is something that would be picked up at the integration branches, the integration jobs, rather.
No.
No?
No.
So builds went through fine, basic test, all the tests ran fine, nothing exploded?
There was one small explosion, but a lot of tests were still passing.
Ah, okay, cool. We should talk about that.
Yeah.
To see what lessons we can learn from the process. Robert is seeking a mic. Oh, you're returning, okay, to your coffee. It's important to return to coffee. Anything else, guys, before I start keeping you from cookies, which I would hate to be the one to do? Okay, so let's go ahead and, there is actually a full fast-phased Boron release plan up there with dates and, dates in a circle, circles and arrows and a paragraph on the back of each one explaining what it is. So we can actually move to that. I think we've identified, quite a lot of the things that need to be done mechanically. And so, this is something we can actually do and consider as we look at this from a TSC point of view for what we want to do for the Boron release. Cool. Thanks. Feel free to walk up and chat with me about any aspect of this. Presume when you find them after you're on release artifacts, is that this SR is released, say, 4 weeks after the initial release, which is the halfway point for kernel. So basically you get these steps that go out for kernel relatively swiftly, but there really are strictly only for bug releases. One of the unfortunate problems we've had is because our cycles are so long, we've had a ton of pressure to put features in RSRs, which we have not always resisted. But if, to your second question, what happens if I discover I need a feature? If the answer to, oh crap, I'm 3 weeks in and I've realized I'm missing a feature is, dude, I'm really sorry, that's gonna be another 4 weeks. That's much different than I'm 3 weeks in and I realized I need a feature and, oh crap, sorry, come back in half a year. So part of it is it reduces some of that pressure. Yes.
The second question is not to necessarily to you, but more to Phil. Is the community, I mean, not in terms of the release dynamics and things like that, where we have the press release, where we have things like that. Are we okay with a release every 2 months? I mean, currently the way we do the release, we have the press release, we have it's a bit of a big affair. Will it be a little too much for in terms of the logistics? And the second thing is, will the users tire of having a release every 2 months? I mean, the users of the news community over.
And just to widen it a little bit more, the question, fast seems scary to me because of.
So talking through what some of this looks like, right? Because it's not particularly complicated, but it helps to visualize things. So right now, the old life cycle has been 6 months. So we got 6 months, we're all coming together, and we release. So for the new cycle, you'd have basically 2 months. So you'd have a release in 2 months, a release in 2 months, and a release in 2 months. So phased. Phased is a tiny bit harder to picture, but it's actually not that complicated. So if the line you see on the screen represents the kernel projects, so the kernel projects would spend 2 months and they'd release their Boron release. Then the protocols, 2 months later, would release their Boron release. And from the place that you get the release from kernel, protocols begins consuming release artifacts from kernel. Now, this gives you a lot of nice effects if you're protocol. So how many people have occasionally had something upstream break you and you actually are stuck? I'm sure it's more than that. So the nice thing about release artifacts, if you're a downstream project like protocols or apps, is that you continue to get exactly the thing that you continue to get. So you do your development work, things don't change out from under you. And then, of course, apps, 2 months, right after protocols release, apps do their 2-month cycle and release. And then at the very end, you have the overall Boron release, the little purple sun there in the picture, which is the point at which everybody has gotten their Boron release out the door. Now, the natural question you may ask yourself is, okay, kernel has now released Boron. What do they do now? Of course, the answer is they go on to do Carbon. So while protocols is working on Boron, kernel is working on Carbon. And then once kernel has released Carbon, protocols has now released Boron, they start working on Carbon. And the picture continues down the way. And of course, the question then, of course, is what after Carbon for kernel? And of course, they start working on nitrogen. Are there questions? Right. So there is a certain priming. So go ahead, Avishad.
Yeah. No, I mean, as per this pipeline diagram, the Carbon will be actually in November if this is in September.
Overall Carbon.
Yeah.
So overall Boron would release roughly September.
Yes.
Overall Carbon would release roughly 2 months after that.
Yeah.
Yes, please.
So I guess the main idea here is that the protocols in the apps, they have a stable target, right? It's not moving.
It's certainly one of the things that's beneficial here, yes.
But there's going to happen the case where there's a bug. I find a bug in, if I'm in protocols, I find a bug or a problem in kernel.
Yep.
And I guess you're going to address that, or how would that work? Would it be like stable branches from previous? And what if all of a sudden I realize, oh crap, I forgot that I needed another feature from upstream?
Right, so you've got a couple things to answer for that. So the first thing you asked is basically, what about bugs? So clearly, you have to, when kernel releases Boron, they have to have a stable Boron branch. and clearly the need to do SRs. Now, the current proposal for dealing with bugs Hello. So, fast-phase boron has been moved here from Inspire 2. So, as soon as folks settle down, we'll go ahead and get moving. So, go ahead and settle in. All right, so how many of you have actually followed any of the fast-phased boron conversation on the mailers? Okay, cool, excellent. How many have no idea what fast-phased boron is? Oh good, this will be more fun. So, fast-phased boron. What is fast-phased boron? It's fairly straightforward. So fast just means that we do shorter release cycles. So rather than having a 6-month release cycle, we have something that's shorter, say 6 months, say 2 months, for example. Phased. So what phased means is that you actually phase the release process. So that first kernel releases, the kernel project's release, then the protocol project's release, then the app project's release. Now, so that gives you a phasing process whereby, for example, the protocol projects can always consume release artifacts from the kernel projects, because kernel has already released its version of this, the version of the release that protocols is working on. So then, and of course, then what is boron? Amorphous boron is used as a rocket fuel igniter and in pyrotechnic flares. So it gives a distinctive green color to flame.
The overhead we have when we release for people like Ann, and now if we're worrying about that every 2 months and it's taking 2 weeks of our lives, then when are we doing real work?
Yep, no, I'm happy. I actually have an answer for that. Okay. But let's hear, let's cue it up, man.
Yes.
Phil, so concise.
So I don't think it would be too much of a problem from a press release standpoint, but I do think we will scare our users away if we are providing what we say are equivalent releases on a 2-month basis. They will have a hard time figuring out how and what to consume. So we might want to think about differentiating releases as something lighter weight for a couple of them and then heavier weight for another. That would, again, slower the whole heart palpitations of our users. But I have a feeling that was kind of already part of the plan. So I think that's how you adjust for that. But yeah, if we did release every 2 months, no, our users would be generally unhappy. And I think, again, our own infrastructure would probably also be a little bit challenged as well. But like I said, I think Ed's probably thought through some of this as well.
Yeah, no, I've got a few things there. So as we get further on, we'll talk about how to handle the long-term support release. Because we have examples of other communities in open source, Ubuntu being a classic, that the development community is used to moving extremely fast, way faster than an enterprise class user even wants to contemplate. And additionally, as we start looking at this, there are some increases in the support for releases because we're accumulating more releases more quickly. And so you also need to mitigate that. And so the mechanism that's been discussed in the mailing list for all of this is the long-term support release. So every third release is an LTS release, every 6 months, just like we do now. And